This video is to help you with your mid-year review. This is for grade 8s. It is a review of squares and roots. So if you are preparing for your mid-year, it's a good idea that you have this out and you are watching this video so you can rock your quiz on Friday. So we're not going to do all of them because there is a great number, but I'm going to select a few and show you exactly where the concept is. So the first one says, which numbers below are perfect squares? A perfect square is an example of a number that you can make a perfect square out of. So for example, the number 4 is a perfect square, and I'll show you why. If I have 4 squares and I rearrange them, I can rearrange them into a perfect square of squares. Now 4 is also a perfect square because I can take the root of the square and get a solid number. So let's do another one that is a perfect square. 16 is a perfect square because if I have 16 squares, I can make a perfect square made up of 16 squares, just like that. So if I had, say, the number 15, well, 15 is not a perfect square because if I stack up all of those squares, I can't get to a perfect square. So 15 does not work. If I go for the root of 15, well, let's take a look at the root of 15. I'm going to go for my scientific calculator here. I'm going to go 15, and there is my handy little root button. Oops, I had to do it the other way. My bad. Let's get back to regular. I guess I had to go root 15, there we go, and equals, and I get like 3.8729, etc., etc. I did not get to a full number. That's because it says that if I were to do 15, my root would not come to a complete number. So 15 is not a perfect square number. So if we go back here, we can clearly see 15 is not a complete root number, nor is 26, nor is 65. However, I could have a square that is a 10 by 10 array, so that one would be a perfect square number. Now it says find a square root of each number, the second one. This is easy. The square root of 16, well, that's like if I were to put it in here. This is some dog challenge for you, SPL. If I were to put the root of 16, root of 16, I would see that it is 4. And once again, to review, like we said before, if I had a square that was made up of 16 squares and I tried to find the root or the length of one side from which it grew, that would be 4 squares wide. And so that explains how we get to the root of 16 being 4. So if I look at these other ones though, well, that is really difficult. Oh no, 49 is actually pretty easy. My bad. The root of 49, that means if I had a square that was 7 by 7, the root would be 7. The root of 196, I think that's 13. I'm just going to double check that. Root of 196 equals 14. That's what it was. Oh, you can't really see that. But anyhow, I put in root of 196 and it got to 14. Let's see if I can get that to clarify a little more. Well, hopefully it'll come clear when my reflective surface goes away. And the root of 400, I already know from the top of my head, is 20, but I could always check that with my calculator. So when I go here, it says 11 squared. That means if I had 11, a line of 11 squares, let's say this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If I were to grow a square from this root so that there was 11 rows of 11, how much would it be in total? Well, I know that 11 times 11 is 121. So that would mean that I have 121 there for 11 squared. This means what is the root of 64? Or if I had 64 squares wide, such as this one is 64 squares, the length of one side would be 8. Like so. Now this one says copy the area, or find the area of each square. Well, this one would be 4 times 4, so the area would be 16 squares squared, like that. Write the side length of each square as a square root. So that means that the side length is 4. That is the square root of 16. Let me skip past this one. If you know a square number, How can you find its square root? Use diagrams, symbols, and words. Well, there's a few ways. Like I've got a square number of 64. Well, here's a couple ways. One, of course, I can use a calculator. I could say square root of 64. There you go, you've got 8. So I can do that. Or I could see what times what equals 64, and I could count up. I could think of them 1 times 1, 2 times 2, 3 times 3, 4 times 4. I had a student a few weeks ago that did an excellent thing. They weren't sure what this meant, so they actually made a list. And they went 1 times 1 equals 1, and 2 times 2 equals 4, and 3 times 3. And they kept going up like this until they realized that 8 times 8 equals 64. So that's how they found the root of 64. Another way you could do it is you can draw a picture where you actually have a square with 64 in it, and then count how many up on one side. So there's several ways that you can do that. Let's see. Let's see. Okay, square. What's the area of this square? Oh, this is an interesting one. Let's take a look at number 8. It says copy the square into grid paper, and it says, what is the area of this square? Well, you can always take it like this, and you could find what the side length is, and then just multiply it by that. There's several ways to do this. This one might be a good one for you to come to me for. Find 12 times 12, and then it says the root. So this one you would do it in 2 steps. So 12 times 12, and then do the root. Times 12 equals 144. 144, the root of 144 equals 12. Because timesing something by itself is the exact opposite or inverse of finding a root. This would also be like saying, what is the root of 12 squared? Well, that would cancel out. Squaring something and finding the root of something cancel out. So the answer becomes 12. So let's do the other one to see what it is. It says 34 times 34, and that is 9b right here. So the first thing I'm going to do is 34 times 34. I don't know that off the top of my head. I know 40 times 40 is going to be around 1600, so it's going to be something like that. So I'm going to go 34, oops, you can't really see that, times 34 equals, it says 1156. However, I know that the root of something is what times itself equals that number. So I already know the answer is simply 34. Because timesing something by itself is the exact opposite of finding the root of a number. Now, a lot of students were really confused by this last one I noticed whenever I give it to them. It says use guess and test to estimate each square root to 2 decimal places and record each trial. So this is simply a guess, and then you can test it on a calculator. So here's what a good guess would be. So I have 17 squared. Well, I don't know what 17 squared is, but I know for a fact that the root, or not 17 squared, sorry, the root of 17. I know the root of 16 equals 4. And I know the root of 25 is 5. Well, I'm going to look at this like a number line. I've got 0, 5, 10, 15, 20. Looks like an even longer number line. 25. So I know the root of 16 is 4, and I know the root of 25 is 5. So the root of 17 is probably slightly, just slightly, more than 4. So I'm going to guess maybe that. Just a guess. Let's take a look. So 17, oops, I have to hit root first, don't I? Root button of 17 equals 4.12. Well, it looks like I was pretty close. Now, how did I do that again? I knew the root of 16 is 4, the root of 25 is 5. So I knew 4 and 5, and 17 is right here, so it must be just a tad more than 4. So my actual answer, my estimate, was 4.06, but my actual was 4.112. I was pretty darn close. So I hope this helps you. This is your mid-unit review for squares and roots. Your quiz is on Friday. If you're watching this and it's sending you a little cross-eyed, please come see me, come hang out on a break, and we'll try to clarify it and make sure that you're on top of your game.